Theorem 4. Show that there exists a natural embedding of n into second conjugate space n star star. Proof: let n be a arbitrary normed linear space and let x be a vector in n. Consider the scalars valued function f of x defined by f of x small f equals to small f x, where f belongs to n star. To show that capital F of x is linear by the definition of capital F of x, alpha f plus bg equals to alpha small f plus bg x, where small f and small g belongs to n star and alpha and beta are any scalars, equals to alpha f of x plus beta g of x equals to alpha capital F of x small f plus beta capital F of x g. Now norms of f of x equals to supremum of modulus f of capital F of x f small f, such that norms of small f is less than equal to 1, equals to supremum of modulus small f of x such that norms of small f is less than 1, less than equal to supremum of norms of small f into norms of small x such that norms of small f is less than 1, which is less than equal to norms of x. Equation 1. Thus capital F of x is bounded continuous and hence a continuous linear functional on conjugate space n star. F of x is called a functional on conjugate space n star induced by the vector x and is called a induced functional. Now we define a mapping phi n to n star star by phi of x f of x for all values of x belongs to n. To show that phi is 1 1, phi of x equals to phi of y, which implies phi of f of x equals to f of y, which implies capital F of x small f equals to capital F of y small f belongs to n star, which implies small f x minus small f y equals to 0, which implies x minus y equals to 0, which implies x equals to y. Therefore phi is 1 to 1, phi is linear. Let x y belongs to n, then for all scalars alpha beta phi alpha x plus beta y equals to capital F of alpha x plus beta y. If small f belongs to n star, then capital F alpha x plus beta y small f equals to small f alpha x plus beta y equals to alpha small f of x plus beta small f y equals to alpha capital F of x small f plus beta capital F of y small f equals to alpha capital F of x small f plus beta capital F of y small f equals to alpha capital F of x plus beta capital F of y small f. Thus f of alpha x plus beta y equals to alpha capital F of x plus beta capital F of y. Hence phi alpha x of plus beta of y equals to alpha capital F of x plus beta capital F of y equals to alpha phi of x plus beta phi of y, which proves the linearity of phi. Further, norms of phi of x equals to norms of capital F of x, which is less than equal to norms of x, equation 2. If x is a non-zero vector in N, then there exists a functional small f0 in conjugate space N star such that small f0 x equals to norms of x and norms of small f0 equals to 1. So norms of x equals to small f0x is less than supremum of modulus small f0x such that small f0 belongs to N star and norms of small f0 equals to 1, which is equal to supremum of modulus f of x capital F of x small f0 such that norms of small f0 equals to 1 equals to norms of f of x equals to norms of phi of x, equation 3. Combining 2 and 3, we have norms of phi of x equals to norms of x for all values of x belongs to N. It follows that therefore that the mapping x to capital F of x is a isometric isomorphism of N into second conjugate space N star star. This isometric isomorphism x to capital F of x is called a natural embedding of N into second conjugate space N star star.